100 times, I have to go and modify in 100 pods. So for that reason, whenever you have a controller in place, so you will modify the controller instead of modifying it on the control unit. So once you modify on the controller, it will be getting modified on the control unit automatically. So here if you have one pod, no problem. For a case, if I have 10 pods, so you have to go and do this 10 times this same modification. So which is a tedious job. So as an orchestration principle, what they did is, so whenever you want to modify anything, you'll go to the controller, you go to the configuration file, so main deployment file, you modify there, automatically it will be reflected on the pod. So instead of going and modifying on the control unit. Control unit is a pod, controller unit is the deployment, or you can say the replica set. So there is a control unit. So that's the reason why we are modifying the deployment file. So it will be automatically modified in the pod. So no need to go and individually modify it. So that's what the orchestration rule is. So whatever you want to modify, do that in one place. So minimize our work. So instead of
got it.
Under different things. So that's the reason why we do it on the deployment rather than doing it on the pod. Even if you try to do it on the pod, it will not be reflected because the controller won't allow you to do it, because only the controller you have to modify it. If you try to do it on the pod, it will not be reflected. What happens is that pod will be terminated, a new pod will be created because that is not matching with the controller unit. So always you have to modify it on the deployment only.
Okay, got it. Yeah.
Okay.
Thank you.
Yeah, then we will go to the next section, which is the third chapter we have completed so far. Second chapter we have completed so far, the 2 sections. Now we move on to the last section. I hope we will be finishing with this today. Introducing the dynamic storage. So as I told, storage is a very vast concept. Now Red Hat is going to release another separate course on Red Hat OpenShift storage itself, because a lot of storage systems are supported by the Red Hat. Okay, so by the OpenShift actually. So a lot of supports are there, and there are a lot of internal parameters to be like OpenShift supports the storage, and how to control that storage things, how to optimally use the storage, and how to optimize the storage for for storing the container things. So there are a lot of nitty-gritty details into that. So here we will see at the very introduction level. So that too we are seeing the dynamic storage. Why we are seeing a dynamic storage? Because here the work is reduced. Like we have to do a minimal work on the dynamic storage when compared to the other types of storage. Here the work is like very minimal. So that's the reason we are learning about like dynamic storage. It's like an introduction to what is storage, just to get a taste of how the storage is managed in the OpenShift. But this is not everything, so you should remember that there are a lot of things with respect to storage. There are a lot of configurations you can do. There are a lot of storage plugins are supported, so there are a lot of things to the storage. This is just about an introduction, just starting with what is storage, what is the OpenShift storage, and why I need it. Okay, so starting with persistent storage. So persistent in a sense which we actually refers to the permanency of something. Like, so the synonym meaning of persistent, something which is permanent or permanence for that object. So here it is about the storage, how you are going to store the content or store the data of a container file system permanently. That's the idea behind it. So this is what a persistent storage, and we'll see that in an overview. So we're going to see the storage classification, how the storage is classified depending on the application requirement. Okay, so one thing you have to remember is that when you deploy the application, when you containerize and deploy the containerized application, so the application won't have any storage storing capability. The application will run as a container. So you can generate data to that application. You can able to generate your own data to the application. The data will be generated, will be holded in the container. But the problem comes when the container is terminated, when the container is destroyed. So whatever the data you have generated, over the container, that is gone with that container itself. So once you destroy that pod or the container, so this is what we call sharing the lifetime. The storage shares the lifetime of the pod. As long as the pod is alive, you have access to that data element or data. Once the pod is terminated, so this is gone. So this is what we call technically the ephemeral nature. So ephemeral nature of the container. So any container, so you are creating. So not only in this Kubernetes, any, like generally if you are creating any container, the container by no means it's not going to have any internal storing capability, because the container itself is running as an isolated process. So it will not have any means to store the data permanently. So once as long as the container is running, you have the data. So once the container is removed or terminated, the data is gone. So if the container is stopped, still you have the data, but if the container is permanently removed or terminated, the data with that container is almost gone. So you cannot retrieve that back, the data, because that ephemeral nature of the container which is running as a process doesn't have any storage permission to store the data. So how to provision the data? How to provision the storage? So we have a classification for that. Go to that. So how to classify the application depending on the storage requirement. So whether I do need to provision storage for all the application which I create, or I need to provide the storage for only a particular kind of an application. So I'm going to classify. We are going to see the classification depending on that. So what are the classification we have for the storage? First is the application. So here I'm talking about the containerized application. I'm not talking about the standalone or the application deployed over a server. I'm not talking about that application. Here I'm talking about containerized application. So depending on the memory requirement, there are two kinds of application. One application is called a stateful application. You can classify application to be stateful when the data collected by that application is critical. For example, take a database as an example. So when I run that database application as a container, so I'm going to generate databases. I'm going to generate database tables. I'm going to store my information in that particular database. Okay, so I'm going to do that. So here for me, I'm generating the database is a place where I'm going to store my data and retrieve the data when I require. So main purpose is to generate data. So and this data need to be permanently stored. So this is for now, the criticality of the data is very important. So data is very critical to me, because if I lose the data once the customer is accessing, so he cannot have access to that particular data. So that is very critical for me. This kind of application where the user generated data is very critical. So where I need to provide some means to store that data, that kind of application is called a stateful application. So where the data is very critical. So where the user generated data is very critical, that we call that kind of application as stateful application. Good example of that is database application. And there are some other application for which the data is not critical. So even if the application is terminated and restarted, I don't have any problem. So only a problem, I might have some downtime. Apart from that, I don't have any problem. So that kind of application, for example, think like a front-end application. So presentation application or presentation layer of application, where you're going to present to the user something like the HTML page and CSS page, where your job is to present the content to the user. So your job is not to collect the data, store the data. So your just job is to present the user. That kind of application is called a stateless application, where the data is not critical to me. Even if I'm restarting or I'm stopping or terminating the application and starting it back, I'm losing nothing. But the previous case, I'm losing the data. So that is a stateful application. Here it's a stateless application. I'm not losing any data. So rather than maybe some glitch may be there when I restart it, when I terminate and do it, maybe I lose some time, but I'm not losing any data. So this kind of application is called stateless application. An example, good example of that is front-end web UI. So front-end application where you present your information to the user. That's all. So when the user inputs the data actually doesn't stays in the front end. It may be going back to the next layer. So it may be going back to the database layer and get stored over there. But data is not permanently in the front end. So front end is the data is not critical. So this kind of application is called stateless application. So you have to classify. So you have to think about before provisioning the storage, because storage is a costly thing when it comes to the enterprise level, production level deployment. So you have to see whether the application is a stateful or it's a stateless in terms of data criticality. So whether the data you're generating Fine, this is the classification depending on that. So after classifying this, now we have to in a position to see how to provision the storage. There are two ways to provision the storage for the application, the permanent storage. One way is called one way to provision the storage is called bind mount. Okay, so bind mount, in bind mount what I'm doing is wherever the container is running or the pod is running, so in our case then the worker node, okay, wherever the container or the pod is running on the worker node, that worker node itself will be acting as my storage point. I'm going to store the data on that current worker node itself where it is running. Itself will act as a storage point. Okay, and this is fine for a small level deployments. This will be okay, but when it comes to the large production, so this is not an optimal solution, because if my worker node is acting as a storage point itself, so there are chances that this worker node may go down. So if the worker node is down, then there is a chance that I cannot access the data. So the bind mount will not be like a scalable solution, so or optimal solution for the large level production. But a very small level, like for like non-prod environment, testing environments, I can use this option. So where I wouldn't want to go for a centralized storage system, so which may prove to be a costly one, I can use this option. But this is absolutely not suitable for the production type things, because there is a vulnerability like this storage node itself, the worker node itself may go down. So in that case I cannot access the data, so I lose the data. So this is not an optimal solution from the production scenario. So I go for the second option, so it uses the local storage, local host itself for the storage. And the second option is volume mount, where it uses some centralized mechanism to store the data. So I'm going to store my content as a volume, it's a file system, in a centralized manner. So maybe my like NFS or some centralized storage system. So that storage point may be outside of the cluster. So there I'm going to store my application data, so that when in case I'm requiring that data back, I can retrieve that data from there. So I can provide some kind of high availability, so I can form some RAID system to store the data, so that the data is highly available. So I can do that. So I can take care of that a separate way. So because the storage is now centralized and it can be taken care separately, they can provide some provision, some kind of high availability to the data, so the storage, so that the data is permanently available. So this method is scalable and optimal in case of production scenario, so where you have a centralized node to store your data. So this is a volume mode. So this is what we are going to see in our section. So next, this volume mount can be provisioned in two different ways. Okay. So one is static provisioning, another is a dynamic provisioning. Okay, so how I'm classifying static provisioning or dynamic provision, just depending on PV and PVC. So you might be unfamiliar with this term PV and PVC. We'll be visiting this, what is PV and PVC. So short, PV stands for persistent volume, PVC stands for persistent volume client. So in the volume mount, you can do a provisioning statically. So that means the PV and PV are manually mapped. For time being, just understand the terms, like what is PV and PVC. Just PV and PVC are manually mapped. So in the dynamic provisioning, PV and PVC are dynamically mapped. So in the dynamic provisioning, I have less work. In the manual provisioning or static provisioning, I have more work. Like I have to manually map it, and I have to see that this is getting mapped, and I have to maintain that things. But here I have a less work to do. So we are going to in our chapter. So our chapter is about dynamic provisioning. So our chapter is about OpenShift dynamic storage. So we are going to see this class. So for an application, stateful application, under the volume mount section, so we're going to see how to provision the dynamic. So how to provision the storage dynamically. So there are other options. So these options we are not learning in depth. So like options like static provisioning, bind mount. So these things we are not going in depth about this. So later on we can study about this later, more about this later on. And there are also other categories of storage also. Like when you take the storage by default, like storage you can provision for a block based storage, or you can have file system based storage, you can say object based storage. That things are there. So here we are going to see about just a file system storage. So I'm going to store a file system storage. If you want to store some other kind of a data like object storage, or if you want to store the data block based storage, so if you want to do that, there are other ways to do that things also we are not going in depth here. Just we are going to see normal a simple file system, how the dynamic provisioning is helping me to store the data. So there are a lot of things to data storage. So here we are going to just touch the surface of storage mechanism. Just we are going to see the very basic level, so how the storage is going to work. So there are a lot of things into the storage. If you want to learn the storage itself, it will take a separate course to learn about it. So here just we are going to touching the surface. I'll give some references so you can later on refer to that, so how to use it, that kind of storage to provision the permanent storage to the data of the application. Okay, so now we'll come to the next term, which is so we have seen the persistent storage overview. Then we come to this one, persistent volume and persistent volume client. So what is, we shortly call this as PV and PVC. PV stands for persistent volume and PVC stands for persistent volume client. So why do we have two factors? So the idea behind is, I have a fixed physical storage and I need to provide a storage to the application which is running inside the cluster. I want to provide a storage to this. This is the idea. And I have two components, so two entities, you can say PV and PVC. Why I do have these two entities, the PV and PVC? What is the reason for going for these two entities? The reason behind these two entities that but you need to have this, whether you are going for the static mechanism or static provisioning, or if you are going for the dynamic provisioning, you should have this. This is the hierarchy. So when you want to provision any storage, this is the hierarchy. This hierarchy cannot be changed. This is the hierarchy, but way this is provision may be changed. So sometimes it may be dynamic, sometimes it may be manual. Okay, and here why do we have two things? We can, why can't we have only one thing through that you can do? Otherwise, why can't we have directly attach the storage to the application? So why do we have two type of things? So the reason for having it two different entities or two different objects or resource is that we need to partition our, or we need to, can say we need to divide our workload on depending on the different teams. Like we can have two different teams, like operational team and the developer team. So I want to divide the workload. So why I want going for the workload division is one team or one person may be familiar in one kind of, or specialist in one kind of things. Like the developers know or they can say how much, what is the storage requirement for their application. So which file system in that particular application need the permanent storage. So they can say that. So they do some kind of benchmark testing or a unit test. So they will do some kind of testing and they will see what is the critical data. So which is critical to them. So what data need to be permanently stored and what data that doesn't require storage. So they can provide this information. So they are the specialist in that things, the developers. On the other hand, developers are not more specialized in the managing the storage. So they may not be specialist in optimizing the storage. So they not be know how to manage the storage. So how to get the storage, how to optimally use it, how to handle the different storage systems. So they may not be familiar with that. So there is a gap here. So on the other hand, there are operational persons who are specialist in storage management. Any system administrators, they basically know about managing the storage. So at least at the basic level, they know how to manage the storage, like NFS, ISKC, this kind of storage system. So how to manage it, how to optimally use it. So they know about it, but they don't know about the application requirement. So they can optimally know how optimally use the storage, know how to use that storage in optimized way, but they don't know about the application requirement. On the other hand, the developers know about the application requirement, but they don't know about the they don't know about the storage optimization. So there is a gap between these two. So to bridge this gap, so we have this PV and PVC. So here the administrator creates something called PV. So out of any storage technology, whether it's NFS or ISKC, he creates the PV. So what the developer will do, developer is going to raise a request. So he identifies he want to provision a storage for his application. So to some file system he want to provision a storage. So he raises a request for 1 GB of storage. The request goes to the administrator, and the administrators look for what is the optimal storage available. So he will create a 1 GB of storage and provision it back to the developer. And developer, what he will do is, once the storage is ready, so once the particular storage point is ready, so the developer will go and claim this storage. So you can see this is the developer is now going and claiming this storage created by the administrator. Administrator keep on creating the storage. So he doesn't care about where this storage is going. So he just creates it and keeps it over here. So it is a role of the developers to claim this storage and attach this storage to the application, to the pod. So it's what a claim. So this is what a persistent volume claim. So claim is the process of attaching a storage to the application, and PV is the process of generating the storage out of the main storage, like out of the physical storage. So that is the PV. So PV will be generated by the administrators, and PVC will be something the developers will claim that storage. So when you look at this picture, that you can see one PV will always have one PVC. So there will not be the case where multiple PV will share multiple PVC will share one PV. So always if you have generated PVC of 5 GB and you have attached to the application, that 5 GB must be utilized by the application, or 5 GB will be only for that application. So you cannot for example, if there is 4 GB for 1 GB as utilized by the application, 4 GB is not utilized. So you cannot utilize that 4 GB. 4 GB is now only can be utilized by the application, or not it will be idle. So you cannot map it to the other application. So always remember, this is a thumb rule. So one PVC will have one PV, so from the physical storage. So one PV may not have will not have multiple PVCs. So this is the thumb rule. So one PV, always one PVC. It will be mapped like that. Okay. So this is what PV and PVC. Hope now this is clear. Then we go to the now something called dynamic provisioning storage. Okay. And dynamic provisioning. So as I told, the static provisioning static provisioning. So now the dynamic and static nature now revolve around how this PV and PVC are generated. Okay. So now let me go to this. So here, if the PV and so we have something called static. The static PV is generated by the admin. PVC generated by the developer. So then this both are manually mapped. So this PV and PVC are manually mapped. So there is a static provisioning. PV and PVC are manually mapped in case of static provisioning. In the dynamic provisioning case, what happens is, so the PV, so you can say PVC, PV and PVC are dynamically mapped. It's automatically mapped. So dynamically mapped. How it is dynamically mapped? So here the admin will create something called storage class. So he is going to create a storage class. So this will be created by the admin. So once he created the storage class, so that is done. So here the developer will create the PVC pointing out to the storage class. The developer, he will create the PVC, or you will point to the storage class. So here the responsibility of developing the storage. So storage class will be the responsibility of storage admin. So the storage class is nothing but instead of, for example, instead of that developer developing individually the PVs, so what they will do is they will create a storage class itself. For example, I want to create a NFS storage class. So they will just keep that storage class, they will create that storage class itself, and whenever the developer required that, they will require storage, they will point out to the storage class. Automatically that storage will be like PV will be created dynamically, and that will attach to the PVC. So the storage is created in dynamic way. So now the administrator doesn't worry about creating that individually. So the individual request will not come to the administrator and he will create that, then it will be manually mapped. That work is reduced. He creates that storage class and keeps that storage class. His job now for the administrator is just to add the storage at the back end. So he will keep on adding when the storage is being consumed. At the front end level, he doesn't have any work. So he's just he creates that, he maintains that storage class, and whenever the developer asks for the storage, he will say this is my storage class, get the storage from there. So just he will mention the storage class, he will get from the storage there. So when the necessary storage are like exhausted, it is going to add the storage at the back end. So that's what the work of the administrator here. So this is what the dynamic mapping. So here we are going to see how this is happening. So here first thing we need to create a storage class. So the storage class is already created in our classroom environment. So we need not create this here. So for the sake of just to use it in a simple way, storage class is already created. So in real time, you will be creating a storage class. So for the different technology, you will be creating a different storage class. So you can go to this reference for knowing more about the storage class. So in the Kubernetes, you'll find this reference. So where you can learn more about the storage class, because the storage class differ with respect to the particular storage system. I'll go to the storage class in the Kubernetes. So the storage class provides a way for administrator to describe the classes of the storage they are offering. So what storage they are offering, whether it is a NFS storage or a cluster storage or CHEP storage or cloud-based storage or like AWS storage. So what storage they are offering. So that is, this storage class will be helpful to define that. So we have here two files to create different storage class. For example, if you want to create a storage class out of in the AWS using the EBS Elastic Block Store, I want to create a storage class, you can use this definition file. This is a declarative file. Using that, you can able to create that resource. Here you can find the version, you can see the storage kind of storage class, you can see the name, you can provide any name, it's saying that's low. So here important thing is to mention the provisioner. So here the provisioner is a way to access the particular storage. So it will be acting like a driver between the actual storage and the storage which the user is interacting. So it will be a driver class. To provisioner will be like a driver class to get that storage, to interact with the storage. So it's like a medium to interact with the this is pertaining to the particular storage type. If you are using a different one, this will vary. So the parameter type will be different. So you can go through this documentation about the storage class, how to create this. Since we are not creating the storage class in the lab, so you can go through this documentation. This will be useful for you. So if you want to study more about the storage, this example. So you can learn about this one. Storage class is a means of classifying the storage over here. Okay. So in the lab environment, so they have already created a storage class. Here you can see OC get storage class. The storage class is NFS storage, which is already created here. So the provisioner for this is NFS storage provisioner. So this is the provisioner. This is the driver for getting that storage. Okay. Now we'll understand how to provision the dynamic storage. So after learning about different terminologies, after understanding about the different methods, the static provisioning and dynamic provisioning, so we are going to understand how to provision this, how to use it for the storage. So now we have here the storage class, we don't have the all these things are created. Then how to utilize this? So how to create the storage class? We are going to how to create the how to utilize the storage for the application. Already the storage is there. How to utilize it for the application? Okay. So as per our lab scenario, so we have here the utility mission. So which utility instance we are having here. This utility instance will act as my storage server. So this is going to act as my NFS storage server, okay, which is this instance, which is like outside the cluster. This is going to act as my NFS storage server. So as per our lab scenario, so in real time we can have it in the cloud or somewhere else. So here this utility mission. So apart from doing the routing function between the two different networks, it is also going to act as a storage point. So during the introduction we have seen, so you can go through that introduction. You can see that this utility mission is over here. This is acting as a router device as well as also as a storage server. So here this will act as my storage server, the utility mission. So here I am going to store my okay. So we'll build a scenario to understand this. So we'll build an application and we'll see how to provision a storage for the application, how the storage is getting stored over here. Okay. So we'll build a scenario. We'll go to the paint again. So let us say this is my OpenShift cluster. This is my OpenShift cluster, and here is my storage point. That is, here is my utility VM virtual machine. I can say this is the instance. So this is my storage point. Okay. This is my cluster. So I want to interact. I want to store the content from the cluster to over here, application content to this utility VM. So now we can go to this. I can open up a new terminal. So I'm just going to get into this mission over here. I'm going to do a SSH route at the rate of utility. So now I'm into this utility virtual machine. So here you can see df-ht. Here you can see this flash export. This is a path which is used for the NFS. You can use show mount -e. So this is the export path which is shared in the NFS server. And you can see the IP address. The IP address. It has actually got two interfaces. So one interface is interfacing with the other one. You can see this is the IP address of that because these things are in the same network. You can see this master and these things are. You can see this is in the 192 series, and this thing is also in 192 series. These are in the same network. The other thing is 172 series, that is the student network. So we are just saying this, we want to take this IP address which is in the IP address range of the master nodes, like the worker nodes and the master nodes. So we have identified the export path. So here is the export path is /export, which is exported in the NFS, and we have the server, which is the server IP address is 192.168.50.254. This is the IP address of that NFS server. So we just identified this. Okay, so we have this now. Just it's a virtual machine where this is acting as my NFS storage point. And now I want to interface with this. So through the cluster, I want to interface. I want to have a driver. So any storage, if you want to access it, you should have some kind of driver to access the storage even from a server level. So I want to interface with it. So how I'm going to interface with this storage? So for interfacing with that, I'm going to have something called a separate project. They have provided a provisioner. So this provisioner is installed in the lab as a separate project itself. So through that provisioner, I can able to interact with this storage point. So this is called NFS client provisioner. So there is a project called NFS client provisioner project. So this project is created for the purpose of creating that interface pod. So here you're going to have a pod. So here we are going to have a pod. So this pod is called NFS client provisioner. This is called NFS client provisioner pod. And this pod, through this pod, I'm going to interface with it. So on one end, I will be connecting this to the storage class. Another end, it will be interacting with my storage over here. So this is created in our classroom. This NFS client provisioner project, as well as this inside this project, I have this client provisioner. This is created in our classroom environment. So you can find that we are not creating that. So here you can see in the classroom environment, uses an external open source NFS provisioner. So this uses that. The NFS provisioner dynamically creates the NFS persistent volume from existing NFS server. So this is the function of that one. So here it is already there. So we'll identify that. So I'll go to the cluster. So here you can find OC get project. So here you can grep for NFS. So the project. So here you can see one project. The project is NFS client provisioner. So that project is already there. You can switch to that project. OC project NFS client provisioner. I'm switching to that project. So here you will find a pod running there. So OC pod NFS client provisioner pod. You can see that pod, and I can now describe this pod. So I can do OC describe pod. The name of the pod is this one. So I'm describing this pod. You can see this provisioner name. The name of the provision is NFS storage provisioner. So here you can see the server. So the server is actually connected to this one. You can see we have already identified that it is connected to this server, and you can see this is connected to this path. NFS path is /export. You can see the permission. So this is there for this client provisioner part. So you can see we are interacting with this utility actual storage through this client provisioner part. So here the path is the NFS path is /export. Then the server is 192.168. So through that I'm interacting with this one. Okay. So this is what we are identifying. So this you can see the connection. So this is my NFS storage provisioner. The next is this NFS storage provisioner is connected to the storage class. The storage class is already created, and the storage class is something like a cluster level resource. So we have a storage class. So NFS, name of the storage class is NFS-storage. So this is the storage class which is created. So this storage class will be linked to this client provision. So this storage class is already created, so we are not creating it, just we are going to look into that. So if we get storage class, you can see now this storage class is there. You can see the storage class is coming from the NFS. The provision for this is NFS storage provisioner. So any storage class which you are creating, so in the real time also, like any storage class which you are creating, that will have a provisioner detail. So for example, you can create in AWS or Azure, any storage class you are creating, you can see the provisioner information. The provisioner should be there. So through the provisioner only you can access that storage. The provisioner information should be available. So here we have the provisioner as in through the client pod. So we have that. So through that I'm able to access this storage. The storage class will have that information. So here I have that storage class created. So in the storage class you can see the provisioner information is coming, showing that it's coming from NFS storage provisioner. Okay. And this is created now. So we identified these things. So we are not creating anything now. So we already have all these things in place. I told you how to create that on your own, like I have to create the storage class. So there is a definition files available in that. That you can able to create your own storage class out of any storage technology. So here you have the client provisioner. Through the client provisioner, I'm interfacing with the physical, actual physical storage. So we have everything in place now. Now we want to utilize this for the application. So here I want to create this dynamic storage system. So I want to do this dynamic storage. So here, assuming that as admin I have created the storage class. Now developer, I have to create the PVC so that it points to the storage class, and PV will be created dynamically, then it will be linked to the PVC. So I want to do that things over here. So for that we will continue our scenario. So far we have identified in the scenario up to this point. So now I'll continue. Now here I'll go and create a application project. So I'll go to the cluster. So here I'm going to create a application project. So here I'm going to call this project my demo 2. So I'm going to call this project my demo 2. Then I'm going to create an application here. So as we discussed, so whenever we are creating the application, so most suitable way to the application which is suitable for providing the persistent storage is the stateful application. So one of the good example for stateful application is a database application. So here I'm going to deploy one database application. So here I'm going to use MySQL. So I'm going to generate MySQL application over here. So here I'm going to generate a MySQL database application. So when I'm generating this MySQL database application, I need to provision some informations, like I need to provision the MySQL username, and I have to provision the MySQL password. I have to provision the MySQL database. So I have this information over here. Okay, so I just now I'm going to deploy the application. So I need to provision this things, like I need to provide this informations as an environmental variable. So because any MySQL server which you are running, so essentially it requires credential information. So I'm going to provide this credential information as an environmental variable. Using the -e option, I'm going to provide this as an environmental variable. So where I can find the image, so I can go to the repository. So here you can find the MySQL image. You can search for MySQL. So here I will go to the Red Hat training. There I can search for Red Hat training. So here you can find the image for MySQL. So here you can find the MySQL image. So I'll be using this MySQL image. So this is the path of that image under the QA registry. And here you can see the tags. So I have two tags. One is the tag 49. Another is the latest tag. So latest tag, if you just leave it empty, it will be taking the latest tag. So you can specifically, if you want to use a particular tag, you can use the tag which is now here is 49. So here this is the image. So I can take this image. I'll copy this image. So using that, so I'll be deploying the application. So first let me create the project. OC new project. So the project name is my demo 2. This is the project name. I have created the project. So initially I'll not have any application. So you will see everything will be empty. So OC get pods. Everything will be empty. So nothing is there. So I'm going to deploy the application in this project. So OC new app. So I'm going to say the name of the application. Name I'm going to say MySQL DB. So any name you can give. So I'm just saying MySQL DB. And here, before providing the Docker image specification, I'm going to provide here the environmental variables like the MySQL user. So here I'm going to say username to be Raj. I'm going to say -e. So -e MySQL underscore password. So I'm going to say any password I can give, just I'm say Red Hat. Next -e, then MySQL the database. So these are required because without this pod won't come up. So basically I need to provide this information. The database, the password and the username. So database I'm going to say any database like TestDB or something. So next, finally I need to mention the Docker image. The Docker image which you already got from there. So I'm going to use the tag 49. There is a space here. So using this image, I'm going to bring in this application with these details. Now the application is created. So you can see the deployment is created, image stream is created, service is created. So for us, the deployment is very important. The name of the deployment is MySQL DB, which is created. So now I have to check the status of the pod. So say get pods. So it is still creating the container. So you can watch that. You can use W to that. Now you can see this is running. Now the pod is running. Fine. So now the idea behind is, now we need to provision a storage. So I want to provide a storage. So as a developer, I need to identify which file system I want to store. So I don't want to store entire file system. So that will be a wastage of data. So I want to store only the critical file system. So which is required in the later on. So in some case, if I'm losing the pod, in that case I require that file system to be available. So which file system to store, and we have to identify that. So initially there will be no storage for this. So if you just do a OC describe deployment, the name of the deployment is MyDB. So if you grep for the volumes, you can see there is no volume here. There is no permanent volume for this storage. Sorry, for this application. And if you want to test it, you can just go to you can take a remote shell. So OC RSH, take a remote shell of this pod. So I'm into this pod now. So if you do df-ht, so inside this pod, if you check the file system, so you see almost all the file system are temporary, so nothing is permanent. And so here I want to provide a permanent storage for the file system. For which file system I want to provide the storage. Here, when I was creating the application, I mentioned a database. So I mentioned a database called testdb. So with this username and password, when this database is created in the in that MySQL server, which is running as a pod, you can look into that. So you can do MySQL user. So I can log in as a user Raj and password Red Hat. So I can log into the MySQL server. So here I can check the database. You can do show databases. So this is database. You can see now the testdb database is available inside that MySQL server. So I just exit. So the MySQL server is installed inside this container. So inside this container, this testdb is stored in this location /var/lib mysql/data. So if I do a list here, you can find this testdb is available inside this. So there are other files, the permission files to access this testdb. So you can see that. So even you can list the testdb. So you can list the content of the testdb. So initially it will be empty. So you can see, you can list that content over here. So actually I want to store, so say I want to store this contents, or I want to store the content of this file path. I want to store the content of the data. I want to store all this entire information. So I want to provide a permanent storage to this. So this is my requirement. So I want to store, because this testdb, the tested data, whatever the user, whenever the user is generating, so that user generated database is getting stored inside this data, inside this data directory. So I want to provide a permanent storage to this path. So I'm identifying this. So we need to identify. So as a developer, so I cannot store all the data. So that will be wastage of my storage. So I want to store only the data which is required in future, or which is very critical in nature. So which is user generated data. Maybe the user may access that data in future. So for that kind of data, I need to provide the permanent storage. I'm identifying here. Here I'm just identifying the path. So for which path I need to provide the permanent storage. Okay. Now we have identified. So I need to create a volume for this path, which is /var/lib/mysql/data. So this content, so whatever over here, should be stored in the this one, the utility machine. So this is what my aim. So for that we have all this interfaces available. So this is my ultimate aim. I want to store this content. So permanently store this content from here to this one. So now what I have to do is, we are provisioning the dynamic storage. So as I told, the dynamic storage, only thing we have to create is we have to create a PVC. So I'm going to create a PVC over here. So this PVC, so once I'm creating the PVC, so in the PVC I'll mention the climb name. So PVC is called persistent volume climb. I need to give a name for this climb. Then I have to provide the climb size. I need to provide the climb class. So mount path, so on. So we need to provide this informations to create the PVC. So this is the PVC which I'm creating. So once I create this PVC, what happens is dynamically a PV will be created. So PV is always created at the cluster resource. So here, whatever I'm creating out of the project. So this is one project, which is an NFS client provisioner. This is another project. The PVC I'm creating inside the project. Okay. So whatever I'm
Hello, Abdul, we are unable to hear you.
hello. Sorry, I got a call in between. Okay. What we were discussing that we are creating a PVC here. So then the PV will be dynamically created. So here the PV which is going to be generated. So this will be dynamically created. And once it's dynamically created, so this will be linked to this storage class, and from the storage class it will be linked to this NFS client provisioner pod. So through that we will be able to access the storage and store our data from this to here. So this is what we are going to see. So this is the path which is going to, so we are going to store this one permanently. So we are going to create a PVC. And then it will be linked to this PV. So now the PV will be dynamically created. So that's why I just indicated this as a dash points. So this will be dynamically created. So it will not be manually created. So dynamically created. Then, so once you create the PVC, automatically it will be created. Then this will be linked to this. And your storage will be, your actual content will be stored over here. So through this mechanism, the content from this point they will be stored okay. So this will be the path through which the storage will be getting stored over here. So now our job is to create the PVC. So we have identified for which file system we want to create the this one. So we'll create the PVC, then the PVC will trigger the PV automatically. Then it will link to the storage class. From the storage class, it will be interfaced with the storage through the that client provisioner. Okay, so this is what we are going to observe. So now we have identified for which to be created. Then now the second step. So now I'm going to create a PVC. So I'm going to create a PVC through the command line. So I'm going to use a command called OC set. The OC set volumes. So this is the command which I'm going to use. So in this command, I'm going to do two things. One is I'm going to create a PVC. So I'm going to create PVC. Another thing I'm going to do with the same command is I need to update the deployment. So update the deployment. So two things I'm doing. So one is create the PVC. At the same time, so creating the PVC is for the application. So that thing should be accordingly updated in the inside the application. So because application will be not having any volume by default, so I need to update that information. So I'm going to do two things, two actions in one single command. So because if you look at the command will be a little bit lengthier. So just to break down that command to understand different options logically, so that you can remember that command easily. So I'm breaking these things up. So I'm going to use specific options which is pertaining to creating the PVC. So here I'm going to create a PVC. I'm going to say the type PVC. So this is one option. Then I'm going to say hyphen climb name. I'm going to say the climb name. So I'm going to provide a name for this climb. Then I need to provide a hyphen climb class. Then I need to provide the climb size. Then I need to provide the climb mode. So these are the options which is specific to creating a PVC. So I'll discuss, except the climb mode, the size is the size of the storage you required. Climb class represents the storage class. The name, the random name you are going to, identification name which we are giving, the username, and the type is PVC. So these options will be pertaining to the, these options I'll be using to create the PVC. And there are certain options just going to update the deployment. So I'm going to use the options like hyphen add. So I'm going to add. So here I'm going to say the name. So this is the name of the volume. So I'm going to say the volume name. I simply call that as a name. Then I need to mention the mount path. The mount path is the path which you are going to store. So the content which you are going to store, that path you have to give here, the mount path detail. Then I need to provide the deployment name. So because any application we're going to update it, we're going to update that in the deployment. So you're going to mention the deployment name. So whatever the name of the deployment is. So this options will update the deployment. So this is the one single command. So it will do two actions. One, it will create the PVC, and whatever the PVC you have created, you are updating that information inside the application. So that we do just in one shot, we'll do these two things. Otherwise, you have to do it manually. So you create the PVC, then you go and update that information, because application doesn't know you have created the PVC. So you have to update the same information to the application. Then with the application, start using that. So because the application knows where that mount path is, so because the mount path is inside the application, so I need to update this information in the application. So one single command, I'm doing this two things. Okay, so I'm going to do this now. So before doing this, we have identified some facts, like initially it is not having any volume, and so we have identified that file system is not having any permanent file system. So for this path, you can see /var/lib. For this path, you don't have any permanent mounted system over here. And also you can check in the same project. So you can see OC get PV. So PVC, you see, sorry, it should be PVC. So you see that there will be no PVC created here. Okay, so there is no PVC created here. And also in the utility machine, you can verify some things, some informations, like here you can list the /export. So there will be one PV information. This is from the different one. So now I don't have anything. So after creating the PVC, you will additionally see a storage. This is the main storage point. So you will see the actual physical storage over here. You will see additional directory. So if you open that directory, you will see this content. So whatever this content over here, so this content will be saved over this in this utility server, or in this NFS server. So this is what our ultimate aim. So you want to store this content from here through these mechanisms. I want to provision it, or I want to permanently store the content over here. That is my ultimate aim. So I want to do that through this things. So we are identifying different means how this is working, how this is going to work. Okay. So now I'm going to do the configuration now. Now I'm going to execute this command. So open a new terminal. So I'm going to use something called OC set volumes. So if you do -- help, this will show you how to use, what are the options which we are going to use. So here I'm using the specific options. So I'm going to use the specific options like these options: climb class, climb mode, climb name, climb size. So these are the options which I'm going to use, like mount path and add. Then I'm going to use like type. So these are the options which I'm going to specifically use. Here you can see the type to specify that my requirement. In case if you are in doubt about any options, you can just use OC set volumes. You can use this command. You can just get the help command. Okay, so now I'm going to update that here. So I'm going to use that command. So the starting with it will be OC set volumes. Then I'm going to say -type. The type is PVC. So I'm going to just use these options which I already discussed here, with respect to the PVC, with respect to the updating the deployment. I'm going to just use all these options together now. Yeah. So type PVC -- climb climb name. So you can say any name. So I'm going to say MySQL -sto storage. This is the name of the PVC. So climb name. So I'm going to say climb class. The climb class is the storage class name. So you can go to we are going to point out to this storage class. We have already identified that storage class over here. The storage class is, so this is the storage class, which is the name is NFS storage. This is a storage class. So I am provisioning this storage through this storage class. So this PV is going to get created and it's going to communicate to the storage through the storage class. So I need to point out to this storage class. So I'm pointing to the storage class here. Then climb size I'm going to request for 5 GI, so 5 GB. Then I'm going to request for climb mode. So when it comes to the climb mode, we have three options. So the climb mode describes the permissions. In the book you can find a table describing about the climb mode, or you can say access mode. So we have three options. One is read write many. So this option tells that Kubernetes can mount the volume as read write on many nodes. On many worker nodes it can mount that as a read write. So like many worker nodes can write the data to that storage. And here the second option is read only many. So that means this can only mount, but it can be only read only. That means you cannot write the data. That's the read only many. And read write once. So this is one option. Here Kubernetes can mount the volume as a read write only on single node. So only single node can write that information. So many nodes cannot write it. So that unscaled applications, you can use this option. So you are not going to scale some static application will not be scaling it. So in that case, you will use this option. Okay, so one single node option. So we'll be rarely using it. So either you will be using a read write many or read only many. So read write many will be sufficient for us to give permission so that many nodes in a scaled application, so it can write the information to the storage. So here you have to use any one of the options. Here you can use the short form. So the short form for this is given in the bracket itself. If you look at the help here, can see the short form. So for read at many you can use RWM, for read only many you can use ROM, like that. Or you can use the full form like read write once. In a full form you can use it, or you can use the short form. So here I'm going to use read write many RWM. The next thing I'm going to mention is I have mentioned the climb class, climb name. So I think I have mentioned all the things with respect to the PVC. So type, name, class, size, and mode. So I have mentioned that information. Now the next thing I have to mention, I have to mention the information with respect to the deployment. So I need to add name of the volume and all things I'm going to mention here. So I'm going to use ---- add. I'm going to mention the name of the volume, which I'm going to say MySQL. I'm going to say MySQL backup. I'm going to name this volume as MySQL backup. So anything any name you can give. Then the mount path. So mount path. So I'm going to mention this specific path. So which we have identified. So I want to store the data of this one. So this is my mount path from the application. So I need to mention this mount path over here. This is my mount path. Then I have to mention the deployment name. The deployment / MySQL DB. So this is the deployment name. So once you are creating the application, you can find the deployment is created. So you can find the name of the deployment. You can just use OC get deployment to see the deployment name. So now one minute. Okay. So the name of the deployment is this one, MySQL DB. So I'm mentioning this name over here. So now all the things are mentioned. Now I'm going to update it. So now I have mentioned the details, things related to the deployment, as well as things related to the creating the PV. So climb name, climb type, all the things are mentioned. So now I need to update this one. So once it's updated, you will see the changes. So now I'll update this information. Now this is updated. So we'll see the changes one by one. So first you will see this would have created a volume. So previously you can see this is not having any volume over here. So now this same deployment so will hold the volume. If I use the same command here, you can see now the volume is created. So I can use A4 or A3 just to find some lines once after finding that, because the required information is below this line. So I'm going to display that line using this option. I'm going to display 4 lines. So here you can see the name of the volume, which is my MySQL backup, which I have given here as a volume name. You can see MySQL backup. So in that volume name it is created. Now you can see the persistent volume climb is created. You can see the climb name as MySQL STO, the storage which I have given here, the climb name. Then that name it has created the PVC. Now the PVC is created. Now you can see the difference. The second difference, so once when I was into that application itself, there you can see there is no permanent mount for this file system. So for this file system, you can see there is no permanent mount. Now you are going to observe the permanent mount. So here you can see there is no permanent mount over here. So now if I just get into the same application, so if I do OC RSH MySQL, and if I'm getting into the application, if I do df-ht, you can see that this has got a permanent mount. You can see /var/lib MySQL data. So this has got a permanent mount. The mount, it is mounted on the NFS server with this IP address inside this /export path. So this is the PV name. So PV is already created. This is a PV name. You can see the type is NFS. Only thing you can observe, this is 40 GB showing 40 GB. Actually, I am claiming only 5 GB. This is a virtual size. So here you cannot see the actual size. This is a virtual size. So, but anyhow, we can see the mount point. And next things to observe is you have to see the PVC. You can just use OC get PVC. There you can see the actual size. You can see what is the actual size you are climbing. So this is 5G. Now you can see the PVC is created. So previously there was no PVC in the project. When I was running OC get PVC, you see that PVC is not created. And now you can see the PVC is created. And also PV will be created. So you can see OC get PV. So you can observe that there is a PV created. So there are two PVs. This is different PV. The PV which we have created. This is a PV name, and this is a size. You can see this is bounded to the application, which is having the PVC as MySQL STO, and this status is bound. So it's bounded to that. You can see this is the case. Now this PVC is bounded to this PV. It's bound. You can see this. Then we are going to see this data whether is there in the utility machine. So we are going to observe that. So we'll go to the utility machine. So previously when I was checking, so I was having only one directory for different PVC, and now I'm going to check this one. Now you can see the second directory which is having the MySQL PV here. So this is the PVC actually PV name. So you can have this is PV here. You can check, you can list that also. You can see my demo, this one. You list it. You can see the same content. You can see the testDB and all these things, same content which was there over here got stored here. Okay, so whenever you update it, so the new information will be automatically stored over here. So the same content now got a permanent storage. This content is now permanently available. Even if you delete this application, you will have this content stored in that location permanently. You can able to retrieve that back. For example, this is a critical data. The testDB is a critical data. So the testDB is now permanently stored over here. You can able to retrieve back that data from that location. So now we can see that's how this storage worked. You can see that we have started from building this as a scenario. So we have identified different things. So some things which we didn't create it by ourselves, like a storage class, and this is already there. So this is utilizing these things and it's storing these things. And we have created the application. We have generated the data. Then we have created the PVC, and PV was dynamically created and attached to the storage class. Through that, it is able to link to the provisioner, and through the provisioner, I'm able to interface the storage and able to store my content over here. Okay. So with that, we complete this section. So with this practical implementation part, so we complete this chapter number 2. Now we are completing it. So we completed the last section, and there is a guided lab. So on page number 47, so you have the guided lab. This guided lab, so what you are going to do is, it will be an interesting thing to do over here. Here you are going to create a project called install storage. You'll be creating this project. So inside this project, just go here. Let me open the paint. So you'll be creating a project. So this project will be install storage. The project you can give any name. Install storage. So inside this, what you're going to do is you're going to create a pod. So this pod, say you're creating here. So this is going to be a it's not MySQL, it's going to be a Postgres. The Postgres SQL pod. So this pod you are creating Postgres SQL. So Postgres SQL pod you are creating. So this is pod number 1. They're creating. So what you are going to do is you are going to store the content. You are going to generate some database tables. So you are going to store that content in permanently over here. So you are going to store that in the permanent system. So you're going to provide a permanent storage. You are going to create a database table. So to create that database table, they have given here some script. So using that script, you can generate the table, or you can read that script. You can generate it on your own if you know how to create the tables. So you can generate it on your own. So here you create the project, then you deploy the application. So the application will be PostgreSQL. So you will specify the Docker image. Here you have to specify the Postgres username and password. So you will specify the username, password, and the database name, all these things. You will create the application. So after creating the application, for that application, you will set the volume. You set the permanent storage for this application of size 10 GB. So you will specify the mount path, all these things. You will create that with the permanent storage. So after creating the permanent storage, the PVC, you can list that PVC and PV. You will generate some data. So for generating the data, so in this path in the lab, they have provided some script. So once you run the script, it will generate the data. It will create some table and insert some elements on the table. So you can look into you can query the table using this script. This is a script, or you can directly query that if you want. We get into that pod and you can directly query that table. You can find the table. Now after doing this, after storing this permanently, so what I will do is you are going to delete this application. So now the application, you are going to remove it. So the idea behind this is, even if you delete the application, the table will be here. So table will be permanently stored here, and you are going to access this table from a different application. So you will be creating another application, same application, second time you will be creating. So this is going to be PostgreSQL, same application you're going to create it. So you'll be creating this application pod, second one. Then what you will do is you will try to, then you will map this storage which is over here. You will map this storage to this application. After mapping this through this application, you will be able to see this table. You will be able to get this table. You can see the table. So data will be permanently stored even if you remove the application. This is what you are going to observe in this lab. Okay, so you can see that you are deleting the application. So after deleting it, so you are recreating the application. Here you are going to name it PostgreSQL 2. You are recreating the application. So after recreating, if you try to query it, so now I just recreated it. I'm not mapped the data, mapped the storage. Before mapping the storage, if you try to query it, you will see this is not showing any table. And after that, you are mapping the storage. The same storage you are going to map to this application. So after mapping this, then again if you run this same script, you are going to see the table. So this table which is generated during the first application, the same table is there permanently stored in the storage. So you are able to access that table. If you are able to access it, then you can remove that whole application and you can delete the project and you can finish the lab. So that's a very simple lab. So you are going to observe this also very interesting lab to see the concepts which you have learned here. So you are going to generate data with one application. We are going to access the data with other application. So during the practical implementation part, so I have done how to store it permanently. So how this storage gets stored over here. So what is the core mechanism happening here? So that we discussed during the implementation part. So we are going to see a practical use case in the lab. So you can do that lab. So once you've done that lab, so we'll start tomorrow. So you can do that lab today. So now we can do, otherwise you can do it later also. So try to finish the lab by tomorrow before starting the class. Then we'll start tomorrow 9:30 the same time. We'll start with the next chapter. So we have completed chapter number 2. Okay. So any doubts after this? So any doubt in the storage?
So far, no. We will need some practice and maybe later any doubt.
Yeah, okay, sure, yeah. So yeah, the lab will be available to you, so you can use the lab anytime. So the only thing when you're using the lab, see that you are increasing the auto stop timer. So because now I can see this has reduced to 3 hours. So you just increase it so that you can increase the lab working hours. Otherwise, it will automatically stop. So you can increase the timing and you can work with the lab. Okay. So you can work with your leisure time. So you can do it later also. But before tomorrow's class, starting of tomorrow's class, try to finish this lab. Okay. So yep. If you have any doubts, so this is my WhatsApp number. So if you have any problem in accessing the lab later on after the class hours, you can contact me over this. Okay, so this is my WhatsApp number. Also my contact number. You can contact if you want to contact me to the phone. You can contact me also. So you can take a note of it if you want. If you have any doubts or something, you can contact me over this. So today's session we will end. We'll conclude. If you have any suggestions, feedbacks, also you can just WhatsApp me up any feedbacks here, like if my voice is not clear like that. So if you want to give any feedback like that so that we can improve it tomorrow, you can provide that to the WhatsApp. Okay, so thanks for attending the session. So we'll see you tomorrow, same time, like 9:30 we'll start. Okay.
Okay, thank you. Bye-bye.
Yeah, thank you.
Thank you.